Hello and welcome to another video. In this video we're going to be talking about the double under future module in Python, not to be confused with the future module without underscores around it. That is a completely different thing that has nothing to do with it despite sharing the name. But anyway, let's jump into it and kind of explain what that does. So the double under future module is kind of a special module in that it doesn't actually provide any, well, it doesn't provide any useful code. But you import stuff from it to change how Python behaves. You can kind of think of it as like a compiler flag that applies on an individual module. And let's talk about the most recent future. Well, I think it's the most recent, unless I'm forgetting another one. The most recent future flag from future import annotations. And what this particular flag does, and there's a bunch of flags, and we'll go over some of the other ones in a minute. But what this particular flag does is it changes how type annotations are evaluated in a Python module. So by default, let's say we make a class which has a, some sort of class method constructor instead of using double under init. Maybe you need a factory sort of approach, but it's going to return an instance of itself. And I don't know, just make a very simple case of this. And so without this future annotations import here, this actually produces an error. And if we run this, python3 t.py, you'll see that we get a name error that C is not defined. And it's actually talking about this C in this return annotation here, which most of the time, like, I mean, I don't know about you, but I really wouldn't want code in an annotation to cause a crash in my actual code. That's more for like type checking time, and annotations are not exactly, runnable code. They're usually just comment-like code. I actually did another video on annotations. If you want to check that one out, I'll try to remember to link it in the description. But what future annotations does is it will treat all annotations as a deferred annotation. Basically what it'll do is it'll magically turn these into strings instead of the actual names there. And you'll see if I have a string here, this module imports fine. And the same is true if I were to import annotations from double under future. Now this import is purely a side effect, though the module does actually exist. And if we pydoc double under future, you'll see like there's the documentation for this, and if we shift G to go to the bottom of this, we can actually open up the file that contains all of these future flags. And if we open this, you'll see that it is actually a Python source file, and you can actually import the names that it talks about down here. So you can see like these are all of the different future flags that have been created over time. And you'll see that they have two versions on them. So one is the version that they were introduced, so this is the first time you could use that feature flag, and they have a second version when that feature becomes finalized in Python. This is how Python, provides feature preview for stuff that might be a large or difficult breaking change. You'll notice here, like, nested scopes were a brand new thing in Python 2.1, but finalized in Python 2.2. In fact, like generators and the with statement, which are common syntaxes that you see in a lot of Python code, were actually introduced in this very same way. You could use the with statement in a preview mode in Python 2.5, and it became part of the actual syntax in Python 2.6. Now, most of the future flags, or like a large percentage of them, were created to make migration between Python 2 and Python 3 easier. And so you'll see here, like, future division was one of these that was created in that way. Absolute import, which is another one. So what future division is in Python 2, if you divide integers, you will get integer division. But in Python 3, if you divide integers, you will get floating point division, unless you explicitly use the modular division instead. Now in Python 2, you can from future import division, and then suddenly the division works similar to how the Python 3 division works. There's actually some differences with rounding and repers and other stuff, but it's a way to enable some of the Python 3 behavior. Absolute import was the same idea. In Python 2, you could have implicit relative imports, and Python 3 required those to either be explicit relative imports or always absolute imports. The print function is another one, where print was a statement in Python 2, but a function in Python 3. Unicode literals allows you to change the type of string literals. So by default in Python 2, they are str. But if we from future import Unicode literals, then we look at the type of a string literal, you'll get the Unicode type. And again, that was a feature flag that made Python 3 easier to migrate to. This one is a bit of an April Fool's joke / meme. I don't even know if it still works from future import this. I mean, the import works, of course, but if I remember correctly, it allows you to use the less than, greater than, does not equal operator, which, I don't know, I believe this was originally an April Fool's joke, but, you know, made it into the language and still lives on to this day. This is not a valid operator in Python, usually, so if you 5 less than greater than 4, you'll get a syntax error, of course, but, you know, sometimes there's memes. And generator stop, this was a change in Python 3.7 where the exception hierarchy for stopping a generation was, or stopping a generator was split. Before you could raise stop iteration and that would cause a generator to stop, but now you need to raise generator stop, something like that. Otherwise it's a runtime error. And so that was introduced as a feature flag in 3.5 and then finalized in Python 3.7. Anyway, that's kind of the idea behind future imports. There's one other thing that I want to mention here before we wrap this up for today. Future imports must appear before any other code in the file. Otherwise, you will get a syntax error. There is one asterisk there, which we'll go over in a second, and you'll see if we try and run this file, Python 3, you'll see that we get a syntax error. It says that from future imports must occur at the beginning of the file. And this is because Python uses those imports to handle the execution of the rest of the file. Now there is one exception to this rule, and that is docstrings. Docstrings must still appear before any other code, including future imports. This actually causes docstrings to get reparsed twice in Python due to the way future imports work, but that's a whole different thing. If we run this, you'll see that if we look at double under doc, we get foo here. Now, if we accidentally put this after the future imports, this actually causes this to no longer be a docstring, and suddenly double under doc will be none. So it's like a common pitfall, like when you're using future imports. Yes, they have to be first, but they should be after the docstrings. And if you want a linter that will validate this, oh, this is open from previous video. I recorded these all in one go. If you want a linter that will validate this, there is a check docstring first linter that I've added to precommit / precommit hooks, which will, check for this common mistake. And that's, precommit hooks. But anyway, hopefully this is helpful. Hopefully you learned something about the future module, or the double under future module, not to be confused with the future module. And if you have additional questions, leave a comment below or reach out to me on the various platforms. But thank you for watching, and I'll see you guys in the next one.